At the end of this module, you will be able to find distance traveled from a velocity time graph, derive equations of motion graphically. Speed time or velocity time graph when speed changes at a uniform rate or uniform acceleration. When a body moves with a uniform acceleration, its speed changes by equal amounts in equal intervals of time. In other words, the speed becomes directly proportional to time. Thus, the speed time graph for a uniformly changing speed will be a straight line. We can find out the value of acceleration from the speed time graph of a moving body. We know that acceleration is equal to change in speed by time taken. In the figure, change in speed is represented by PQ and time is represented by OQ. So, acceleration is equal to PQ by OQ. But PQ by OQ is the slope of the speed time graph, OP. So the slope of a speed time graph of a moving body gives its acceleration. The distance traveled by a body in a given time can also be calculated from its speed time graph. The distance traveled by the body in the time corresponding to Q will be equal to area of the triangle OPQ, which is equal to half the area of the rectangle ORPQ. So, distance traveled is equal to area of triangle OPQ, which is equal to half into area of rectangle ORPQ, or equal to half into OR into OQ. In a speed time graph of a body, the straight line sloping upwards shows uniform acceleration. In a speed time graph of a body, the straight line sloping downwards indicates uniform retardation. Speed time graph when the initial speed of the body is not zero. The figure shows the speed time graph of a body having an initial speed equal to OB and then accelerated from B to C. In order to calculate the distance traveled from this graph, we have to find the area enclosed by the graph, which is a trapezium. The trapezium is OACB. Area of trapezium is equal to sum of two parallel sides into height. So distance traveled is equal to OB plus AC into OA by 2. Speed time graph when speed changes at a non-uniform rate. When the speed of a body changes in an irregular manner, then the speed time graph of a body is a curved line. Now, graphical method of derivation of equations of motion. To derive V is equal to U plus AT by graphical method, consider the velocity time graph of a body shown in figure. Here, BD equals BC minus CD, where BC is equal to V and CD is equal to U. So, BC minus CD equals V minus U. Now we have acceleration is equal to change in velocity by time taken. So A is equal to BD by AC from the figure. A is equal to BD by T since AC equals T. So BD equals AT. Then the equation V minus U is equal to AT, or V is equal to U plus AT. Derivation of second equation of motion. We have the second equation of motion, S is equal to ut plus half at square, where S is the distance travelled. From the figure, distance travelled under the graph AB is equal to area of trapezium ABDO. That is area of rectangle ACDO plus area of DABC. that is OD into OA plus half into BC into AC. By substituting the values, we get S is equal to UT plus half AT square. Now the derivation of third equation of motion. S is equal to area of the trapezium OABD. We have the equation half into sum of parallel sides into height. That is half into OA plus BD into AC. Half into U plus V into T. But we know that A is equal to V minus U by T, or T is equal to V minus U by A. Substituting the value of T in equation 1, we get V square minus U square is equal to 2AS, as 2AS is equal to V plus U into V minus U. So, V square minus U square is equal to 2AS. In this module, you have learned that in a speed-time graph, the area enclosed by the graph curve and the time axis gives the distance traveled by the body. The slope of a distance-time graph of a moving body gives its acceleration. Derivation of equations of motion graphically.